Now next question, find the value of k for which this line is parallel to the x-axis, parallel to the y-axis and passing through the origin. Say here line is k minus 3 into x minus 4 minus k square into y plus k square minus 7k plus 6 equal to 0. We calculate its slope. Slope is minus a upon b. B is minus 4 minus k square. Slope is minus a upon b. B, that is coefficient of y. So it is equal to k minus 3 upon, say this minus, we are minus minus we are taking plus, so 4 minus k square. This is slope of this line. Now see answer of first question. Line is a parallel to x-axis. If line is parallel to x-axis, if any line is parallel to x-axis means it's horizontal line, so its slope is always 0. Therefore slope is always 0. So slope is 0, that means this value is 0, and ratio is 0 if a numerator is 0. So in this case k is 3. If k is 3, line is parallel to x-axis. Now second question, if line is parallel to y-axis, if the line is parallel to y-axis, if line is parallel to y-axis, that means it is a vertical line, and if any line is vertical, slope is not defined. Therefore its slope is not defined. Slope is not defined, that means this value is not defined. This is not defined. And this is not defined. Any ratio is not defined if a denominator is 0. So 4 minus k square is 0. So that means k square is 4. So k is plus or minus 2. So when k is plus or minus 2, then line is parallel to y-axis. Then third question, passing through the origin. Line is passing through the origin, that means this equation will be satisfied by 0, 0. So if line is passing through origin, then 0, 0 satisfies equation of line. 0, 0 satisfies equation of given line. So in equation, therefore putting x equal to 0 and y equal to 0 in given equation, putting x0 and y0 in given equation, say we are putting in this given equation, I am putting x0 and y0, so what is left? This part equal to 0. So we get k square minus 7k plus 6 is 0. So that means k minus 1, k minus 6 is 0. So in this case, k is 1 or k is 6. See, always remember one point, that any line, see I am putting here a statement. See, if a line, for any line, if line ax plus by plus c equal to 0, it is parallel to x axis. It is parallel to x axis, then equation is free from, it is free from x. If line is parallel to x axis, then equation is free from x. Equation doesn't contain x. So in that case, coefficient of x is 0. A is 0. So in that case, see here, A is 0, k minus 3 is 0. So k is 3. And if line is parallel to y-axis, parallel to y-axis means vertical line. So equation contains only x variable. It is free from y. And it happens when b is 0. And if line is passing through origin, if line is passing through origin, then c is 0. So remember these three statements. Now next question, find the equation of a line drawn perpendicular to this line. Say required line is perpendicular to this line, passing through the point where it meets the y-axis. So required line is passing through the point where this line meets y-axis. So first of all, we find slope of this line and intersection point of this line with y-axis. So here x by 4 plus y by 6 equal to 1. This line meets y-axis at, say here y-intercept is 6. This is intercept form. So y-intercept is 6. So it cuts y-axis at 0, 6. Now we find its slope, and its slope is minus a by b. A, that is coefficient of x, 1 by 4 upon b is 1 by 6. Directly you can calculate minus a by b, keeping this form as it is. Otherwise get this into its standard form, means making this equation free from denominator, getting ax plus by plus c equal to 0 form. After getting this form also you can calculate, or directly also you can calculate minus a is 1 by 4 and b is 1 by 6. So this is minus 3 by 2. So required line has therefore slope of required perpendicular line is m equal to, because required line is perpendicular to this line, its slope will be, this is minus 3 by 2. So take reciprocal and change sign. This is negative, this is positive. So it is slope of required line. Required line passes from 0, 6. Required line passes through 0, 6. So its equation of required line is y minus y1 equal to m into x minus x1. Y minus y1 equal to m into x minus x1, that is 3y minus 18 is 2x. So 2x minus 3y plus 18 is 0. This is required line. Now see here in this question, find value of a p so that these lines may intersect at one point. Means lines are concurrent. Here 3x plus y minus 2 equal to 0. This is equation 1. Then px plus 2y minus 3 equal to 0. This is 2. 2x minus y minus 3 equal to 0. This is 3. So these lines are intersecting at one point. Means these lines intersect at one point. It means lines are concurrent. See, this is line 1, this is line 2, suppose this is line 3. They are intersecting in one point. It means intersection of 1 and 2 lies on 3. Intersection point of line 1 and 2 lies on line 3. We can also say intersection of line 1 and line 3 lies on line 2. Now look here, we want P. P is in second equation. So to find P, what we will do? First of all, we solve equation 1 and 3. Means point of intersection of 1 and 3 lies on second line. So here we can say point of intersection of line 1 and line 3 lies on line 2. So let us find intersection of 1 and 3. So we are solving equation. We solve equations 1 and 3. This is 1, this is 3. So say 3x plus y minus 2 equal to 0. 2x minus y minus 3 is 0. Here this will be cancelled. We are taking addition. 5x equal to 5. This is minus 5. Take on this side. So that is plus 5. So x equal to 1. X equal to 1. Putting in equation 1. So put in equation 1. Putting in equation 1. X equal to 1. So 3 into 1. Plus y minus 2 is 0, so y is minus 1. Therefore, line 1 and line 3 intersect in point 1 minus 1. So this is 1 minus 1. And this point, it lies on line 2. Here 1 minus 1 also lies on line 2. So equation of second line will be satisfied. So putting values, x equal to 1, p into 1, 2 into minus 1. Minus 3 equal to 0. So therefore P is equal to 5. So it is required value. Find the area of the triangle formed by lines y minus x equal to 0, x plus y equal to 0 and x minus k equal to 0. Say here 3 lines are given, y minus x equal to 0, x plus y equal to 0 and x minus k equal to 0. So when 3 lines form a triangle, then to obtain vertices of triangle, we have to find intersection points of these lines. So here, suppose this is a line 1, this is a line 2, maybe this is a line 3. 3 lines are intersecting, line 1, line 2 and line 3, and they are forming vertices. So to obtain or to find vertices of triangle, we solve these equations. So here first of all we solve 1 and 2. So solving 1 and 2, that means intersection of 1 and 2, 1 and 2, we are getting this point. Y minus x is 0, x plus y is 0, so I am putting here equations, x plus y is 0. So if we add these equations, then 2y is 0, so y is 0. And putting y 0 in any one of these two equations, x is also 0. So line 1 and line 2 are intersecting in 0, 0. Therefore, line 1 and 2 intersect in 0, 0. By observation also you can say that these are intersecting in 0, 0. Say here this is free from constant, here constant is 0. So this is passing from origin, this line is also passing from origin. Both the lines are passing from origin, so their point of intersection is origin. That by observation also we can say. Now we solve equation 1 and 3. Solving equation 1 and 3. From equation 3, x minus k is 0. So from equation 3, here equation 3 implies x equal to k. Every point on this line has x coordinate k. That is the meaning of this equation. This is equation of vertical line. So on this line, every point, say if this is vertical line, so every point on this line will have x coordinate k. So putting x equal to k in equation 1, so putting in 1, we get y minus k is 0, so y equal to k. So 1 and 3, therefore lines 1 and 3 intersect in k. So 1 and 3 intersect in k. This is a diagram to understand the method. Now we solve equation 2 and 3. Similarly, we solve equations 2 and 3. Say here, solving equation 2 and 3, x equal to k, and putting here k, y is minus k, y is minus k. So lines 2 and 3, lines 2 and 3 intersect in k minus k. So this we can take k minus k. So vertices of triangle are, therefore vertices of triangle are x1 y1 is 0 0. See, x1 y1 is 0 0, x2 y2, x2 y2 is k k, and x3 y3 is k minus k. We are calling them x1 y1, x2 y2, x3 y3. Now area of triangle. So area of triangle A is equal to, formula is 1 by 2 times modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, and put here this in modulus. So putting values here, 1 by 2 into, now x1 is 0, so 0 into y2 minus y3, y3 is minus k, so this will be plus k, plus x2, x2 is k into y3, y3 is minus k, minus y1 is 0, so y3 minus y1, plus x3, x3 is k, so k into y1, y1 is 0 minus y2, y2 is k. So this is equal to 1 by 2 times 0 into anything is 0. This is minus k square. This is also minus k square. So 1 by 2 times minus 2k square. So this is 1 by 2 times 2k square. So value is k square. This is area of triangle. Now next question. Find the equation of the line passing through the point of intersection of these two lines that has equal intercepts on the axis. So first of all, we are finding point of intersection of these two lines. So see here, we solve 4x plus 7y minus 3 equal to 0 and 2x minus 3y plus 1 equal to 0 for point of intersection. Whenever we solve any two equations, we get point of intersection. So to solve this, look coefficients. This is 4x, this is 2x. So better second equation we multiply by 2. So 4x, first equation I keep as it is. Second equation multiplying by 2, 4x minus 6y plus 2 equal to 0. So now we take subtraction, minus plus minus. So this will be cancelled. 7 plus 6, 13y minus 5 is 0. So y is equal to 5 by 13. So it is y coordinate of point of intersection of these two lines. Now putting this y value in any one of these equations, let me put in second equation. So putting in second equation, 2x minus 3 into y, y is 5 by 13, so 3 into 5, 15 by 13 3 into 5 by 13 is 15 by 13 plus 1 is 0. So 2x is 15 by 13 minus 1. So 2x is, therefore 2x is 15 minus 13, 2 by 13. So x is 1 by 13. So both the lines, therefore given lines intersect in 1 by 13 comma 5 by 13. Now we require a line passing through this point and that has equal intercepts. So let the required line has equal intercepts, x and y intercept, x intercept equal to y intercept, both intercept equal to k. Suppose that required line has x intercept equal to y intercept equal to k. So its equation is, therefore its equation can be expressed as x upon k, this is x intercept, plus y upon k, this is y intercept, x upon a plus y upon b equal to 1. So this is x plus y equal to k. Any line has equal intercept. If both intercepts are equal, then its form is always x plus y equal to k, where k is value of both intercepts. Now it passes through this line is passing from 1 by 13 comma 5 by 13. This line is passing from this point. So this point will satisfy this equation. So therefore, because line is passing from this point, coordinates of this point will satisfy this equation. So we are allowed to put in this equation. So 1 by 13 plus 5 by 13, x keep 1 by 13, y keep 5 by 13 equal to k. So k is 6 by 13. So this value putting in 1, required line is x plus y equal to 6 by 13, that is 13x plus 13y minus 6 equal to 0. This is equation of required line. Now the question is, show that the equation of the line passing through the origin and making an angle theta with the line y equal to mx plus c is y by x equal to m plus minus tan theta upon 1 minus plus m times tan theta. So here this is given line. So slope of given line y equal to mx plus c, its slope is m. Required line passing from origin. So let me suppose that, or we say as required line passes through origin let its equation be y equal to nx, where n is slope, where n is its slope. Because m symbol already used here, m is a given value, so we can't repeat same symbol or same value again in the same question. So we differ the symbol. Suppose n is slope of this required line. Now angle between both lines, angle between both lines is theta. Therefore tan theta is equal to, say here slope is m, here slope is n. So tan theta is equal to m1 minus m2, m1 minus m2 upon 1 plus m1 into n2. If m1 is slope of first line, n2 is slope of second line, m1 and m2 are slopes, angle between them is theta, then we know we have already a result. Tan theta is modulus m1 minus m2 upon 1 plus m1 m2. So that means tan theta is plus or minus m minus n upon 1 plus mn. So now from this step we take two cases. Case 1. Now case 1 is, if tan theta equal to plus m minus n upon 1 plus mn, then from this equation we are going to find value of n. N is a slope of required line, because we want equation of required line. So getting value of n, this means multiplying 1 plus mn on this side, so 1 into tan theta is tan theta plus mn into tan theta equal to m minus n. Now from these numbers we are taking n common, so m tan theta minus n taking on this side, so plus n, so plus 1 times n. This number is shifted on this side, and from both these numbers n is taken common. It is equal to m, as it is tan theta I am taking on this side, so m minus tan theta. That means n is equal to m minus tan theta upon 1 plus m tan theta. This is slope of required line. So equation of required line is, equation of required line is y equal to nx. Y equal to nx implies y equal to, now I am putting this value, n is m minus tan theta upon 1 plus m tan theta into x. So y by x is m minus tan theta upon 1 plus m tan theta. This is equation of required line. That is in case 1. Now case 2. Case 2. Case 2 we are taking negative sign. Tan theta is equal to minus of m minus n upon 1 plus mn. That is, now multiplying this number on this side, tan theta plus mn into tan theta equal to minus m plus n. That is, now we want value of n. So here this is mn tan theta, this is plus n. So mn tan theta I am taking on this, this n I am taking on this side. So m into tan theta minus 1 into n. This number is shifted on left side and n is taken common, equal to minus m minus tan theta. So n is equal to minus m minus tan theta upon m tan theta minus 1. Now here I am changing sign in numerator as well as denominator. So m is equal to m plus tan theta upon 1 minus m tan theta. This is value of n. So equation of required line, therefore equation of required line y equal to nx, putting here value of n, y equal to m plus tan theta upon 1 minus m tan theta into x. That is, y by x is m plus tan theta upon 1 minus m tan theta. This is second form of, or we can say this is required line in second case. So there are two possible values of required line, two possible equations. Now we can represent 1 and 2 combinedly. So representing combinedly 1 and 2 combinedly. So representing 1 and 2 combinedly or together, required equation is y by x. So here this was, this is m plus tan theta upon 1 minus m tan theta. First I have written this second form, m plus tan theta upon 1 minus m tan theta. Now that form I am joining here. When here there is minus sign in numerator, then in denominator there is plus sign. So this is required equation. In what ratio? The line joining minus 1 1 and 5 7 is divided by line x plus y equal to 4. So here we suppose that A is minus 1 1, B is 5 7, and a line, this line is x plus y equal to 4. It divides this line segment in ratio m is to n. And suppose point of division is P. We want this ratio. So say here, let coordinates of A minus 1 1, B is 5 7. We suppose that x plus y equal to 4 divides line segment EB at point P in ratio m is to n. So we can calculate coordinates of P. Therefore, coordinates of P are mx2, that is 5 into m, mx2 plus nx1. So n into minus 1 is minus n upon m plus n, comma my2 7m plus ny1, n into 1 is n upon m plus n. These are coordinates of P. Now P lies on this line. Here, this dividing point, it lies on x plus y equal to 4. So coordinates of P will satisfy this equation. So therefore, putting here these coordinates, value of x is 5m minus n upon m plus n plus value of y is 7m plus n upon m plus n. This is equal to 4. So simplifying this, 5n minus n plus 7m plus n upon m plus n LCM, multiply on the right hand side. So 4 into m plus n is 4m plus 4n. Therefore, 5n plus 7m is 12m. This will be cancelled. 12m minus 4m is 4n. So 8m is equal to 4n. So m by n is equal to 4 by 8. Therefore, m by n is 1 by 2. So required ratio is 1:2. This is required ratio. And using this value, we can calculate coordinates of P also.